In our first video, we introduced the radian, right? And we talked about what the radian is and a couple of other things. But the most important takeaway, or at least one of the more important takeaways that we had in that video, is that 360 degrees is equal to 2 pi radians, right? So now what we want to do is we want to work on how to convert other degrees that you're given, maybe your 90 degrees, 60 degrees, 30 degrees, even like 12.3, right? So random angles in degrees, convert them to radians, right? So now we have this blueprint, right? As long as we have this, then we're good to go, right? So we can convert anything into radians. So let's just say, for example, let's start with something that's very easy. We're going to start off and we're going to this is just going to be a video of examples, right? So we're just going to call this example 1. Right? We're trying to convert 180 degrees to radians, right? Which should be the reason why I'd say it's easy, right? Let's just do this intuitively, and then we're going to use ratios. We know that 180 degrees is going to be half of 360, right? So in order for me to get 180, I just divide this by 2. So which means the radian form, I just also divide this by 2. So the answer should actually just be pi. All right, pi radians, right? Because we know that if 180 is half of this, then that means its radian equivalent should be half of 2 pi. Okay, so our goal here is to get 2 pi. Is to get pi radians for 180 degrees. But how do we get there, right? So essentially, what you're going to do is we're going to say, okay, we're going to use ratios. Ratios tell us that if 360 is equal to 2 pi, then 180 is equal to what, right? So what we're going to do is we're going to say, okay, the ratio of radian of your 2 pi over 360 must be the same thing as this. So we're going to call this theta, right? Must be the same ratio that you'd get if you take the angle for 180 and then divide that by 180 as well, right? So these should be the same, right? So this is what the ratio would be, right? So the ratio essentially would just be whatever I would get if I say 2 pi divided by 360 must be the same if I take, so we know that our answer is pi. If I take pi over 180, because that ratio should basically be exactly the same. So that's how ratios work, right? So in this case, so now we're trying to get theta. So multiply both sides by 180. It's going to cancel on this side. Multiply this side by 180. And then what it's going to do, if you put this into your calculator, or at least we don't actually need to do all that. We just say, how many times does 180 go into 180 once? How many times does it go into 360 twice? And then this 2 is also going to cancel with that 2. So which means the only thing that you have left on the left-hand side of the equation is going to be pi. The only thing you have on the right-hand side of the equation is theta. All right. I hope this makes sense. I hope especially this step over here makes sense, right? If it doesn't, what you just need to do is, in order for you to remember how to convert from degrees into radians, let's just write this as a note. To convert from degrees to radians, multiply the degree value by pi, what is 2 pi over 360, or, right, so essentially on this side, you're also going to have, like, if I have 2 pi over 360 is equal to whatever angle I'm looking for divided by the angle that I'm given, whether it's 60, 90, whatever it is, right? This side can also be simplified, right? Because 2 can go into itself once, and then it can also go into itself, it goes into 360 180 times. So the conversion you can also use is also this pi over 180, which is the same answer that we got over here, because we know that 180 degrees is equal to pi radians. So that means we can use, instead of using 360 is equal to 2 pi, we can say 180 is equal to pi, then what's the angle, right? So you can multiply by 2 pi, or more simply, we can multiply by pi over 180, right? So as long as you know this conversion, then you're fine, right? Just multiply it by pi over 180 in order for you to turn from degrees to radians. And we'll look at the radians to degrees in the next video. Right, so let's look at a couple more examples, just, so that it kind of, makes a little bit more sense. Example 2. What if I gave you 90 degrees, right? So 90 degrees to radians, right? So now we're going to use the new conversion that we've just talked about. We know that 180 degrees is equal to pi. So what's the radian version of 90, right? We're going to call this theta, right? So what we've just said is, what you're going to do is, you're going to say, okay, pi over 180 is the ratio of radian to degrees. So this is your radian to degrees for this conversion, for these two equivalent ones. The ones that we're looking for is something that we don't know, which is theta over 90. This is also another radian to degrees. So these two should be exactly the same. Your radian to degrees for this pair should be the same as radian to degrees for that pair. Hopefully that kind of makes sense. So then from there, what we'll then do is we'll then say, okay, let me just rewrite this. So pi over 180 is equal to theta over 90. Multiply both sides by 90. Multiply this side by 90, right? So that means your theta is going to be equal to 90 multiplied by pi over 180. So this is why we said, okay, in order for you just to go from degrees to radian, just multiply it by pi over 180. So you actually don't need to go through all of this. You just need to take your value of degrees and then multiply it by pi over 180, because even if you write all of these things before, you're always going to come back to this part of the formula, right? So 90 goes into itself once, it goes into 180 twice. So that means the only thing you have left on this side is going to be theta is equal to pi over 2, and that is your radians. All right, cool. Hopefully it's kind of making sense as we go, right? So third example, we're just going to go through a couple more, but this time a little bit quickly, right? So now we have 30 degrees into radians. All right. So again, we know that pi, or at least 180 degrees, is equal to pi. So what is 30 degrees? So we'll call this theta, right? Again, your ratio of your radians over degrees for this pair should be the same as your ratio of radians to degrees for that pair. Multiply both sides by 30, so that's going to be 30. Multiply this by 30. That's going to give you theta is equal to 30. I'm just switching these, by the way, in case, I just took this to the side because I always like my unknown value to be on the left-hand side. So hopefully that's not too confusing. So that's theta is equal to 30 multiplied by pi over 180. 30 goes into itself once, 30 goes into 180 6 times. So your answer for theta is equal to pi over 6. All right, last example. The last example is going to be something, because these are the angles that we kind of know, right? So I'm just going to bring in something a little bit more weird. So 222.5 degrees to radians, right? But then even if this looks weird, the solution is exactly the same, right? So what we're going to do is we're going to say, again, 180 degrees is equal to pi. Then what is 22.5 degrees equal to, right? Formula stays exactly the same. The ratio of your radians to your degrees for this one should be the same as your ratio of radians to degrees for that one. Multiply by 22.5 on both sides. It's going to cancel over here. And then on this side, you're going to have 22.5, right, multiplied by pi over 180. So I'm going to switch them again, right? So pi is equal to 22.5 multiplied by our conversion, which is pi over 180. Now, let's say, for example, the question tells you write in exact form, right? Or whatever, right? So what you want to do is you're going to forget this, right? So don't put this into your calculator, but what you're going to do is you're going to put 22.5 divided by 180 into your calculator. So you might hear me punching mine in the calculator. Or you actually get 1/8. Oh, that's actually an easy number. So this goes into itself once, this goes into 188 times. So what you have left is 1/8 of pi, which is the same as saying pi over 8 radians, right? So cool, right? So again, I'll try to summarize because I say a lot in these videos, but the question is like, what's the takeaway? The simple takeaway for this video, it is in order for you to go from degrees to radians, you just essentially, all you just need to do is multiply by pi over 180. And then you're fine. That's literally what this video should have just been. But yeah, hopefully that makes sense. You know, if you do more questions, we're probably going to do a lot of questions preparing for your exam. So it will make you, hopefully by the time you get to your exam, this is going to be something that comes, you know, as second nature. But for now, hopefully this makes sense. And the next video, we'll just do the inverse, right? So from radians to degrees this time. So yeah, I will see you in that next video.